So thank you so much to our speakers. It's really exciting to see how Big Red 200 is impacting everyone's research. We would love to see Big Red 200 become part of more research stories. So I'm going to go over a brief overview of all of our systems. I'm going to get you all onto Big Red 200. And then after our lunch break, Scott Teague will be showing you how to run some deep learning workflows on Big Red 200. How many people here have used HPC systems at IU before? It's a pretty good amount. Excellent. Just a brief overview, we are here for Big Red 200, but each of our systems are very well suited to different tasks. So we have 4 currently running. Our oldest running one that is still active is Carbonate. This is a general all-rounder system. It has 72 general purpose nodes. This will have 24 cores available to you, as well as 256 gigabytes of RAM. We also have a high memory partition in case that memory isn't sufficient for you. That will have 512 gigabytes of RAM. We also have our GPU partition on Carbonate. If you are here and interested in using GPUs, we have is it 24 GPU equipped nodes, each with 4 NVIDIA V100s each. Those are quite powerful. So if you are looking to run GPU enabled applications, or you have deep learning workflows, this is a great system for you. It also has a lot of applications pre-installed. Since this is one of our older running systems, we have had lots of time to get software on it. So if you are using HPC systems for the first time here, this will be an excellent place for you to start. Additionally, it has Research Desktop. This is a graphical desktop service for our Carbonate users. It will allow you to easily submit jobs to Carbonate, as well as gain easy access to our other systems. If you have any graphical applications that you like to use, Research Desktop makes that super easy to use. Next, we have Quartz. This is our high throughput, high memory cluster. Each of those 90 nodes on Quartz has 512 gigabytes of RAM, as well as 128 cores. So if you have work that can only fit on those large memory nodes on Carbonate, it will work excellently on Quartz as well. This system, as well as Carbonate, are excellent for jobs that may not be able to scale beyond 1 node. So if you can only use 1 core or up to 1 node, those jobs will work perfectly on either of those systems. Next is Big Red 3. This is our Cray XC40 with over 900 nodes. These have 24 hyper-threaded cores, so 48 cores that you can allocate to whatever you want to do, as well as 256 gigabytes of RAM. So this system is fantastic for if you have applications that can scale across several nodes at once. Finally, the reason why we are all here today is Big Red 200. It is an HPE Cray EX with over 600 general nodes. These are 128 core, I believe 256 gigabytes of RAM, as well as 64 GPU equipped nodes. These have 4 NVIDIA A100s each. These are a large step above our V100s, so it is fantastic for anything that requires a lot of computation that GPUs excel at. Now, all of these systems are available to faculty, staff, and graduate students. Additionally, undergraduates have easy access to Carbonate, Quartz, and Big Red 3. Once you're on our systems, you'll probably want to store your data on them so that you can work with your data on our systems. We have 2 wonderful teams that manage these storage systems. We have our HPFS team that manages and supports our Lustre high performance file systems, Scratch and Scratch Project, or Slate, Scratch, and Slate Project. Slate is our quota-based and never purged high performance file system. It has a 800 gigabytes quota allotment. You get a one-time free increase to 1.6 terabytes. So this is excellent for competing against because it has a lot of space available to you very easily, and it is higher performant. You do have to request an account to get one. You can request it just like how you requested your Big Red 200 account. Next, we have Slate Project. Slate Project is an excellent resource for if you are trying to work with collaborators in a shared location. So if you have a lot of data that you need a lot of people to work on, it is fantastic. You get up to 15 terabytes of storage for free. It will accommodate very large amounts of data. Additionally, if you have over 15 terabytes, it is a small, very modest charge to get that. Finally, we have Slate Scratch. This is excellent for your temporary storage. It is purged every 30 days if you aren't touching those files. However, you can theoretically put 100 terabytes on there. This is accessible on Carbonate, Quartz, and BigRed 200. It's not available on BigRed 3, unfortunately. Research Storage maintains and supports our home directories, our geode project spaces, and the SDA. Your home directory is where you land when you log in. You get 100 gigabytes across all of your accounts. So if you have accounts on Carbonate and BigRed 200, you'll be sharing it between those two. This is backed up, but we don't recommend competing against it because it is not a very large amount of space and we have more performant file systems available to you. Next is Geode Project. This is a paid disk-based replicated and mountable storage. You can treat that space as a networked drive on your own laptop. And we have the SDA, which is our tape archive. This is excellent for long-term storage. Once you have completed your work, you can bundle it all together, send it to the SDA, and it will stay there for all time. Data is replicated between here in Bloomington and Indianapolis. So you all will see later that the data center is extremely fortified, but if a tornado were to hit Bloomington, your data would still be preserved in Indianapolis. Your journey through HPC@IU does not have to end today. You can always create more accounts, same way that you did earlier. To get that BigRed 200 account, we have a complete listing of all of our services. I don't want to stop you from getting lunch, so you can find them here. We have additional training and workshops available to you. You'll sign up for those at the same place that you signed up for this. If you have any questions, we have plenty of contacts for you to reach to answer your questions. We all collaborate very closely together, so if you have a issue, send it to any of these emails and we'll make sure it gets to the right place. But these are our HPS, our sysadmins that will help you out in case you're running into a specific system issue. I am part of research applications of deep learning, Rattle. We do a lot of user support, getting you running with your applications. If you have questions about Slate, you can contact HPFS. SDA is a store admin. And then if you have issues with research desktop specifically, you can go to Red Help. So we're going to get on to BigRed 200. Oh, yes. All of our slides for the hands-on portion will be at this github.io.edu. If you all are able to see that. There will be 2 sets of PDFs on there that should have everything that is covered during the hands-on portion. Thanks.
So while Laura is transitioning to the next slide, I did send a link to all of the participants, and this goes for Zoom folks too. There is a link that ends with HPC Day, and at that link, you'll be able to access all of the materials from today, including Laura's workshop and Scott's workshop this afternoon. And that is also where the recordings will be available.
So we are going to get on to BigRed 200. It's why we're all here. We're going to be looking at computer vision data set later in the hands-on demonstration that Scott Teague is going to cover. So we're going to need to include X forwarding when we log on to BigRed 200. And we can do this in several ways. If you have a Carbonate account, you can use Research Desktop to act as a middle ground between your own laptop and BigRed 200 that will kind of help mediate some of the issues and hiccups that may occur when you're trying to move graphics over to your own eyes. Otherwise, you can connect to our systems through either your terminal applications if you're using a Mac or Linux system, or you can use this SSH client if you're using Windows. Now, I'm going to show you how to do it on a Mac. I'm using a Mac. I don't have a Windows PC available right now. However, if you go to these slides right over here, you'll be able to also self-pace in case I am moving too quickly. And if I am moving too quickly, let me know. But the gist of it is that you're going to install an X server. For Mac, this may be X Quartz. On Windows, it may be Xming. If you are on a Mac, you will have a built-in terminal application. If you're on Windows, you can install PuTTY. And then you just restart your computer, you'll open the terminal, or you will open Xming and then open PuTTY, and then you will log on to BigRed 200. So I'm going to show you how to do that on Mac. I already have X Quartz installed on my system, so I won't be doing that, but I will be doing this. So when you have those things installed, all that you will need to do, and I will linger over those slides a little bit longer. But in order to log on to BigRed 200 with X forwarding enabled, you will just need to use SSH -Y, capital Y, your username at bigred200.uits.iu.edu. You will log in with your IU password that you set up when you created your account, and you will use your dual factor authentication method of choice. I have Duo set up on mine. So I will select my preferred phone number with 1. And I'm logged in. And then once I am logged in, I can verify that X forwarding is working with the command XEyes. And you can make it kind of dizzy. There's another one that's called XClock, but it's not as fun. All right, how are our Mac users doing? All right. How are our Windows users doing? And do we have any Linux users in the room? I like you. So are we all on? Are we all good? All right, then I'm gonna just charge on ahead. I'll briefly mention how you could connect through Research Desktop. If you want to learn more about this, there's a KB link over here. There are a couple ways to access Research Desktop. There is a ThinLink client that you can download at sendio.com. Once you download it, it'll look like a nice graphical application. You'll type in your username and your password. It'll still be it'll instead of Carbonate or BigRed 200, you will be using red.uits.iu.edu as your server name. Alternatively, there is another way to access Red through the web client. So if you go to your favorite web browser, Chrome is not my favorite web browser, but it works. Go to red.uits.iu.edu and log in. And again, you'll be using your university password and Duo login. And once you're on, you'll have a familiar desktop layout. There's a lot that I could say about this, but I think that today we just want to look at how we can view and access our BigRed 200 home directory, which you can do very easily through either the home button or just through other HPC systems. And then here, you can get a quick glimpse of what is in your home directory on BigRed 200. We want to log on to BigRed 200, so instead we'll select BigRed 200 terminal through here. And this will look very similar to what I just did on my laptop natively. This is just doing that SSH command. You are also free to use the SSH command in a terminal window on Red. That is absolutely something you can do. This icon will also include the X forwarding along with it. So if you want an easy way to do it and you have your Carbonate account, you can do it that way. Right. So now that we are all on BigRed 200, you're going to want to access your software a lot of deep learning work is done through Python packages. So we will be looking a lot at Python today. Bigger 200 in Quartz uses LMOD to manage your software environment. LMOD is a successor to the module system that Carbonate and Big Grid 3 still use. Most of the commands will be the exact same between the two, so you don't have to learn anything new if you've been using our other systems. I'll show you a few of the classic commands you might be using if you are going to be running on our systems. You can see what modules you have loaded, what software you are able to access with module list. I forgot a word. We'll see that we already have a few preloaded. If you want to see what we have available for you to add to your environment, you can use module avail or module AV, that's just the short version. And you'll see that we have a large, long list of software and programming languages that you are able to access. If you're looking for a specific one, you can use module avail and then the name of the package you're looking for. So I'm going to look for Python. And you will see that we have a few available to you. You'll notice this D next to, say, Python 398. This is the default that will be loaded if you don't describe any further what version of Python you want. You can always look at what a Python will do to your working environment with module show Python. I want to define that I want to look at, say, 3.10.5 with 3.10.5. And it'll show what this package, what this module would do if I loaded it. So it would add all of the necessary library paths to my environment to run it when I use the commands. So if I went to load Python, I can just use module load Python. Now when I use module list, I will see that Python has been added to it. If I don't like Python and I want to remove it from my environment, module unload Python. Maybe I wanted a different one. Maybe I wanted to load Miniconda. You can do it like that. Now when I use module list again, you'll see that it is gone and it is removed all of those paths that it had added from my environment. Now, I will point out that we do have a standard set of Python. We'd have like a standard Python installation that we at Rattle manage and maintain, and we curate that has all of the packages that you may be interested in when you are working, that you wouldn't want to spend the time to install yourself every single time you ever wanted to use Python. This will have things like NumPy, Pandas, the classics. You will also notice on Big Red 200 that we have these Cray Python packages. These aren't the ones that we curate. You'll probably be wanting these ones that don't have Cray at the prepended at the front of it. Now, if we take a look at pip list while I have Python, while I have Python loaded, you will see a massive list of packages that you wouldn't have to install yourself. However, if you encounter something that you need for your work that we don't already have installed, you are always more than welcome to install it yourself to your home directory. You can use the pip install -- user flag and then the name of whatever you're hoping to install. That will install it for you in a way that your environment will be able to pick up. Additionally, if you are trying to install something that requires, say, HDF5, there's a chance that you haven't loaded the HDF5 module. So if you ever run into any issues or errors while trying to install a Python package, go and check with module avail to see if you are missing a certain piece of software that you can really easily add into your environment, and then try running pip install again, and you'll be able to get it up and running in no time. On our systems that have GPUs enabled on them, have them equipped, We have a curated deep learning software stack available as a module that is managed by Scott Teague. You can check them out with module AV Deep Learning. These will include all of the classics such as TensorFlow and PyTorch, as well as CUPy, which is a CUDA toolkit utilizing equivalent to NumPy that enables the GPUs to help you churn out your NumPy related processing tasks. So I'm going to look at the deep learning module. We currently have this one available as default. We will eventually be swapping to this one as default. This will have the latest and greatest. So if you are interested in seeing what's new in deep learning, that is a way that you can check. We'll also take a look at what is included with this module. Importantly, it is also loading all of the necessary integrations with CUDA Toolkit. This will add all of the libraries for CUDA Toolkit into your environment to allow you to use all of the wonderful things that NVIDIA has put together to best utilize the GPUs. Additionally, some of you may be really interested in using Conda environments. They're an excellent way to port in software and applications that are really useful to use with these GPUs. If you need to use environments, Miniconda installations are available to you on BigGrid 200. Anaconda as well is available on Carbonate as a module. Note that you will need to install CUDA Toolkit into your Conda environment and or load the CUDA Toolkit module to utilize your GPUs when you're running. Additionally, we recommend that you use the command source activate your environment name when loading up these Conda environments. We sometimes find that Conda activate or Conda init is trying to add things to your bash profile when you are logging in and to kind of make your life easier when loading them. However, when you log onto the HPC systems, are also trying to do the same thing. So sometimes they collide in strange ways. When you're on BigGrid 200, you land on what is called a login node. What you want are the many wonderful compute nodes that are very powerful and have all of the stuff that you want to use. We manage the system resources through a scheduler. Here at IU, we use Slurm, and we put your requested work into a queue. And once the resources are ready for you, you can run your work. So what you will typically do is build and install and set up your job environment on the login node. And then you will run your job on a compute node by either submitting a Slurm job script, we call this a batch job, or you can use commands to request resources to use interactively. We call this an interactive job. I'm only going to briefly go over this because I think that the piece is almost here. So you can find more detailed information on this here. I'll just briefly describe what you would do for a batch job. What you do is you create a glorified text file called a job script containing SBatch directives describing the resources you want, and then followed by the commands that you would use to run the program on the command line. So here we are asking for output and error files to come out as your job is running, called job name. This will give you your job ID, your unique job ID. We are also asking for one task per node, and then we want only one CPU to work on that one task. So one process, one CPU for that process. We only want one node. We want to run for 1 hour in the general partition. So no GPUs on this one. We are asking for the nodes that don't have the GPUs. For 100 gigabytes of memory, give it a name. You can load your modules, of course. You can go to whatever directories you need that have your application or your data. And you can use srun, the name of your program, if you are working parallel. Otherwise, if you're running Python, this may just be Python, the name of your program. Once you have this job script, you will submit your job script with SBatch, the name of your job script, and you can walk away and wait, and your job will run as soon as your resources are available, and you can come back to it later and look at your output. So it is very set it and forget it. If you want to be hands-on while you're working on your tasks while on the compute node, or if it has graphical things that you want to view while you're working on it, you can also use an interactive job. There are a few ways to do this. You can use salloc command to allocate a node for you to SSH2 later. This is what Scott Teague is going to show you how to do. Alternatively, you can use srun with --pty bash at the end of your command to launch a bash session on a compute node. So here I'm running on the GPU debug partition for just 30 minutes with one node or with one task. By default, if I don't define how many nodes I want, I'll get one. I want one GPU. This is where you can request multiple GPUs. And here's where I'm asking for an interactive session. Once you're on there, you can run all of the commands that you would want to run. Here I loaded the deep learning command and I ran the NVIDIA SMI command to look at my GPUs or my GPU, the only one that I wanted. So I'm gonna let you all get your pizza. And then afterwards, Scott Teague will show you how to run some deep learning workflows. Thank you so much.
All right. So are there any quick questions for Laura while her presentation is fresh in your mind? Scott, 1 second.
If you manage to get logged in, stay logged in, and you'll be able to play along with the next talk. So
Thanks, Scott. Was there a question? Great.
Is it two modes? There are a CPU mode and GPU mode when I log into BigGrid 200?
So when you log into BigGrid 200,
Yes.
you're just hanging out on a shared node that doesn't really have, you will be on CPUs, you won't have access to GPUs. You would then shape up what your tasks you want to run and then submit it to either just the general partition that would just have CPUs, or you can submit it to the GPU partition, which would have access to those GPUs.
So by default, it is CPU. Then I have to specify if I want to run my job in GPU.
Yeah, all that you would need to do is just ask for GPUs one. If you need to specify NVIDIA, let's say A100s, you would also put A100:1. But I believe that by default, if you don't specify, you're going to get the general GPU. But yeah.
Okay. And what about the amount of memory?
So you can request on BigGrid 200, I believe 256. So 240, yes, thank you.
Okay.
All that you would do is on this line right here, I would also put --mem, MEM, and then space, and then how much up to 240 that you want with a G.
What is the default?
The default is, I don't have that on here.
16?
Yeah, 16. So
Okay.
So definitely, if you are wanting to get all of the memory, and I mean, if you're going to be on the node, I think you should get all the memory. So
Okay.
definitely ask for 240. Yeah.
Okay, thank you.